So this is my completed assignment for Lesson 92, building a calibration program in Python or Qt to calibrate the 9-axis. This is probably my favorite project. I enjoyed learning about PyQt and figuring out how to do all the things. So this is the actual running program. We have the 9 graphs, and then I have a print calibration values and a save calibration values button. I figured I'd show you the running program and then show you the code. So each device has its own start calibration button. If you push the calibration, like for the accelerometers, it turns blue and it starts collecting the calibration data. I'm not going to subject you to a lot of me getting it exactly right. I'll just move it around a little bit so you can see the idea. My X magnetometer has always been a little finicky. I eventually can get a nice circle with it, but I'm not going to make you sit through me figuring it out. So I'll just stop it now, and when you see it stops it, everything turns green. It prints the offsets and the scales. And then if you were to come down here and print the calibration value, you can see over here it prints the accelerometer offsets, the scales, and then it tells you that the gyroscope and the magnetometer data is not available. If you were to save it, it actually would save a CSV file in your default Python programs folder. And here, if you open it, you can see, again, it lists the accelerometer offsets, the accelerometer scales, and then tells you there's no data available. So now we'll calibrate the other two just so you can see them working. So if I would do the magnetometers, and again, I'm not going to subject you to me trying to get these exactly right. I know it looks like there's nothing on the magnetometers, but it's just because I had scrolled in by mistake. The scroll bar over here, the wheel on my mouse, doesn't actually run the scroll bar, so I get confused. But now I do need to scroll in on these to actually see anything, it seems like. But again, these are finicky. I eventually can get them right. I was able to get the, I'll just stop it. So again, you don't have to sit and watch me do this. I was eventually able to get the compass within a degree or two of accurate. But it takes me a while. So that's saved. And again, after each calibration process, it will print the data you got just during that individual calibration as well. And then the last thing, and this takes actually a minute, because you can see when I start the calibration, it tells you to keep the GY87 still for 1 minute. It's actually about 50 seconds. I do 1,000 samples. Every 50 seconds is when we had set the graph to update. So I won't make you sit through that. I'll pause it and come back when it turns green. Right, I'm back. I think it's soon going to turn green. I figured I would come back so that you could hopefully be here when calibration's complete in there, and then it'll print the offsets. And again, here on the output screen, it tells you that the gyro calibration is complete. And then if you would go back to the actual window and print the calibration values, you can see you now have them all: accelerometer offsets, accelerometer scales, gyroscope offsets, magnetometer offsets, and magnetometer scales. And if you would come back here and save the calibration values, you'll see we now have another CSV file in the folder. And if we open it, it has all the values saved. So, like I said, I really enjoyed figuring out how to do the file saving and all this. It was a fun project. So now I will come back here, stop the window, and then just show you the code. I did change the imports a little bit so that I didn't have to constantly type the Qt widgets before I would do some of the other commands, as well as the Qt core. I had to get the CSV file to do the save. I had to get the date time to add or order to, I don't know if you noticed, but the files that are saved have the date and time they were saved. So if you do multiples of a day, you can easily identify the latest. This is all pretty simple, similar to what we had done. These are all the different variables that I set up for the different devices. And then here's the main window layout. I also did change this a little bit to add the scroll area. I figured out how to do that so I could have the scroll bar on the side. I tried making the graphs smaller, but I liked them bigger with the scroll bar. And then here's the layout for each different row. I used the same for load to populate the 3 graphs on each row. Here's the gyro layout. Here's the magnetometer layout. And then here's the bottom button layouts. And then here's the toggle calibration. The accelerometer and the magnetometer are very similar to what we had done for the magnetometer previously. I changed obviously some of the function of the labels, but the actual what happens is practically identical. The gyro calibration is a little bit different. Once they just push the button, it tells them to hold still. This is the finish actually. This is the start calibration. Once they push the button, you can see when the button's clicked, it goes to here. It tells them to push the button, hold still, and then it resets the arrays, and then it starts a single shot timer for 50 seconds. And then when that timer completes, it sends it back up here where it calculates the means of the raw arrays. And those are the sets as the offsets. And then here again is the magnetometer calibration. That's very similar to what we had done previously. And then the update plots, again, it's practically the same, just with the 3 different values. So the accelerometer data, there's the raw and the calibrated, and it depends on what it's set to as to what's being populated in the graphs. The gyro data also has raw and calibrated, and the magnetometer has raw and calibrated. And then here's the function for printing the results. Again, it's based on if it's calibrated. So the accelerometers, the gyros, or the magnetometers, what's printed. And then the same with the save. Learned about the extend functions to add the different appropriate printouts or data to be saved into the file based on if it's calibrated or not, and then the CSV write file. And then this is just a timer that we had used before to start when the plots are updated. So, like I said, this is a long video. I know, I'm sorry, but this was a fun project. I enjoyed digging in and figuring it out. I'm interested to see how you managed to take what took me a full, complete day, morning to night, into an hour lesson. But I'm going to watch that as soon as I post this. Thanks again for doing these lessons.